Good afternoon, everyone. Here's your flipped review video lesson on what slope is. To understand slope, you need to know the context of how to use it and when it is used. Slope refers to the steepness of a line on a coordinate plane. It can be positive or negative, as represented in the graphic shown here. The reason you may have a positive or negative slope is based on the function that is in the graph. Functions are relationships between an x or y variable. They are shown one of two ways. F of x is how you would say that, or y equals x. What you usually will see in 7th grade is this format. However, you can see it like this and it would mean the same thing. And the next few slides are going to explain just exactly what that is. In the function y equals x, the line is saying that for every x coordinate, you can find the coordinate of y by looking at the line. Okay, this is what this is saying. Y equals x, first of all, is no different than saying y equals 1 times x, because the coefficient is understood to be 1. That being said, this is how you would apply that. If you remember how to plot points on a coordinate plane, you always use the x number first, followed by the y. The blue dot that you see here has an x coordinate of 1 because I moved over 1 to the right. Then I went up 1. So its coordinate is 1, 1. Now, the way this works in a function is, if I were to substitute the 1 here into this variable, what I'm saying is y is equal to 1 times 1. Well, 1 times 1 equals 1. That's why I went up 1 coordinate. If y happened to be 2, as represented here, if x equaled 2, then my y coordinate would also be 2. Here's another example of what I was just explaining. In this example, I'm saying that y equals x. Remember, that is no different than saying y equals 1x. All of these points on the coordinate plane could be found by following the rule of this function. What this is saying is if x equaled 1, then y would equal 1. If x equaled 3, y would also equal 3. If y equaled 5, or if x equaled 5, the y would also equal 5. The reason that this always works is because what I'm doing is I'm plugging in the value of x and I'm multiplying it by the coefficient. In this example, the coefficient is understood again to be 1. So if I say that x equals 5, then so would y. They can always be shown on a graph. This function is expressed as y equals 2x. What this is saying is, if x equaled 1, then y would equal 2. How I got that? Look at this dot and pay very close attention. Remember that my original function looks like this. If I say that x equals 1, as shown here, that is the equation of y equals 2 times 1. That 1 came from x over here. That means y equals 2, which is at this coordinate. I went up 1, or over 1, and then up 2. Same thing up here. If x equaled 2, then y would equal 4. This is because I'm substituting the value of x for this number up here. So that becomes y equals 2 times 2, y equals 4. And that will become a pattern along that coordinate plane. And then if I connect those dots, then I've made what we call a linear function. The root word in linear function is line. So it's always going to make a line. If it didn't make a line, it wouldn't be a linear function. Here's an example of a function where y equals 1/2 x. So whatever x happens to be, I multiply that by 1/2 and then I end up with my y coordinate. In this example, x equals 2. So I'm saying y is equal to 1/2 times 2. Well, 1/2 times 2 equals 1. That's where that point ended up being. If x equaled 4, if I multiply 4 times 1/2, I end up at 2. If x equals 6, and I multiply that by 1/2, y would equal 3. Here are examples of when the slopes are negative. The only difference is I am multiplying one of these numbers by a negative integer, which is going to change things. If x equaled -1 here, then y would also equal -1. This is the function y equals -x. If x equaled -2, then the y would also equal -2. If x equaled -3, then y would also equal -3. Here's another example of a function where y equals -2x. In this function, if x equaled -2, then y would equal -1. If x equaled -4, then y would also equal -2. This is because, again, I'm substituting these numbers here for the variable, and I'm then multiplying it times -2, which is going to end up giving me my coordinate. To calculate slope, you only need to look at the coefficient of x. That's the number in front of the variable. In this example, the slope is 3. If you're given only a line with plot points, you can also calculate slope, not knowing what y is equal to. Here's a line where you've been given a coordinate plane with a straight line. The way that you would do this is look for where points cross. Very easy to identify points. I'm going to look here. This crosses nicely at this point. I'm then going to figure out where my next one is, which is located here. To calculate slope, I'm going to go up and then over. I went up 4 and over 1. That slope is represented as 4 over 1. That as a fraction reduces to the whole number of 4. That's my slope. If I wanted to write this as a function, it would be y equals 4x. Always work your way up. When you count over, counting to the right is positive and counting to the left is negative. In this example, the slope is 2/3 because I went up 2 and to the right 3 between 2 points. Here's an example where the slope is -1/3. I went up 1 and to the left 3. That gave me -1/3. You can explore slope online by using the Graphing Calculator app or the website Desmos. You can also use our TI-73 calculators in class. Ask questions in class if you have anything further you want to know.